Good day to you all. Today's going to be a overview of Mountain Math, set number 20, and we will go through numbers 1 through 7 today. And then Thursday, tomorrow, I will post 8 through 12. All right. So, just as a reminder, Mountain Math, what do you do? Where do you get your numbers? How do you know what's set? So, if you go to classwork within Google Classroom, you can go to your to-do list right there and it will tell you which Mountain Math sets we're working on. And this week it's 19 and 20. So we are working on set 20. Now, once you know what numbers you have, you can, or what you can do is after this tutorial is made, you are able to go to Virtual Learning Math and you can click on Mountain Math. And once you click on Mountain Math, you have a couple of things that pop up. So one, you have your graphic organizer if you've lost it or you messed up or you just want to take a look and create your own graphic organizer. That's right here for you in a PDF form. You can open that up, you can print it out, or you can just look at it. And then you also have a Mountain Math walkthrough, what to expect with Mountain Math. What problems are we working on? How come we're only doing to 12? All of that's explained within the walkthrough here. And then you have set 19, you have 21, 22, and 23. After this tutorial is made, you will see Mountain Math set number 20 in here for you to look at. And as we scroll down, you can see that Mountain Math Set 19 has 2 tutorials. Okay, that's an explanation of some of those trickier problems, number 8 and number 12 especially. Okay, so let's get started on Mountain Math Set number 20. I have already gone through and plugged in my numbers. I'm opening up my numbers here just to show you that they are located here. 1 through 12. All right, so now that I've got all these numbers copied in, I am ready to go. So here is my Mountain Math graphic organizer, and we will start with number 1 today. Our numbers are 4,940 and 4,690 for number 1. Again, you have this sneaky little question down here, even or odd. You gotta look at the ones place, all right? Any number that has a 0 in the ones place can be assumed to be divisible by 2, and any number that you can divide evenly by 2 is an even number. Both of our numbers today are even. I went ahead and wrote the word form of each number, and now I'm ready to continue with my expanded form. Expanded form is the value of each digit. How much is each digit worth because of where it is in the number? The 4 is in the thousands, therefore it's worth 4,000. The 9's in the hundreds, therefore it's worth 900. The 4 in 940 is in the tens place. That makes the value of that 440, and then you have a 0. Whenever you have a 0 in a particular place value position, you do not need to include it in your written expanded form. 4,690, you can see that the 4 is in the thousands place, therefore the value is 4,000. The 6 is in the hundreds place, therefore the 6 has a value of 600. The 9 is in the tens place, 9 tens, or 9 times 10 is 90, and we do not have a digit other than 0 in the ones place, so we do not need to include that. Now, we want to add 100 and take 100 away from each one of these numbers. Okay, your thousands place, right, is 4. Your hundreds place is the 9. So when you're dealing with a 9 in any place value position that you need to increase by 1, well, that 9, the only place that it has to go is 0. And whenever you move a digit up from 9 and make it a 0, the digit to the left must also go up 1. So in this case, the 9 in the hundreds place is going to go up 1. The only place that it has to go is 0. So that 4 to the left has to be 1 more as well, which would make it 5. And the digits to the right of the 9 will remain the same. So adding 100 to 4,940 is 5,040. Now let's take a look over here at 4,690. Say we wanted to, just as an example, to stick with this 9, say we wanted to increase 4,690 by 10. That means that the 9 would turn to a 0, and the 6 to the left also has to go up 1. So this would become a 7. The 4 stays the same and the 0 stays the same. So adding 10 to 4,690 would make it 4,700. Now we can be on task. All right. So we are adding 100. That means that we are adding 100 to this 6. We are going to increase that place value position by 1. That becomes a 7. The 4 stays the same. And so does the 10s and 1s place. 4,790. Now let's take away 100. We're going to decrease the 9 by 1, so that becomes an 8. The 4 now stays the same. 4,840. This is going to be 100 less, so that 6 will turn to a 5. 4,590. Now comes the opportunity to multiply by 10, 100, and 1,000. Remember, when you're doing this, just write down the digits to the number 4,940 without your commas. You can do that for every one of these next 3 problems. And we are going to add the appropriate 0, include the appropriate extra 0. And so if we multiply 4,940 times 10, we're going to tack on an extra 0 there. 1s, 10s, 100s, comma. Here we're going to multiply by 100. We need to add 2 additional zeros. 1s, 10s, 100s, comma. And when multiplying by 1,000, you're going to add 3 zeros to this number. Now that's the shortcut way of multiplying any number times 10, 100, or 1,000. If you were to work out your traditional algorithm, area models, expanded form, you can get the understanding of why we are adding the 0, the 2 zeros, and the 3 zeros. Same thing over here to the right. 4,690, no commas, but I'm going to add the appropriate 0 when multiplying by 10. I'm going to add the appropriate zeros when multiplying by 100, which is 2, 1s, 10s, 100s, comma. And then same thing with 1,000. I will add 3 zeros. 1, 2, 3. There we go. All right, now we can compare the numbers. 4,940 and 4,690. We cannot use the thousands place to compare these numbers. They are the same digit. But however, if you move 1 digit over, you can see that you have a 9 in the hundreds place and you have a 6 in the hundreds place. These are 2 different digits, which means you can use the hundreds place value position for comparing these 2 numbers. It's the first place value position starting at the left and working your way right where the digits are different. So the 9 is larger than the 6, making the entire number 4,940 greater than 4,690. All right. Now to the questions of how many 1s are in the tens place, how many 10s are in the hundreds place. Well, first you got to find out, well, what is the value of that 4 that's in the tens place? And then how many 1s does it take to make that value? So the value of that 4 is 40. How many 1s does it take to make 40? If I had $40 in $1 bills, I would have 40 1s. How many tens are in the hundreds place? Well, what's the value of that 9? It's 900. 900, okay, is the value of the 9 in the hundreds place. How many tens does it take to make 900? So if you work backwards, you have 900 is equal to 10 times what? And that would be 90. 90 tens in the hundreds place. Over here, we have a 9 in the tens place. How many ones does it take? How many ones are in the tens place? Well, it takes 90 ones to make 90. How many tens are in the hundreds place? Well, we have a value of 600 sitting in this tens place. So 600 is equal to 10 times what number? 60. You have 60 tens sitting there for 600. Alrighty. Looking at 158,053 for number 2. We are looking for the value of the 8, and we are looking for the value of the 3. Same thing for every single time you do number 2 in Mountain Math. The value of the 8 is in the thousands place. That value is 8,000. The value of the number 3, well, the number 3 here sits in the ones place. The value of 3 ones is 3. Now we can round each one of these numbers to the appropriate place, the tens place, the thousands place, or the millions place. So real quick, when rounding numbers, one strategy is to use number lines. 158,053 to the tens. So if we are looking at this number and we want to round it to the tens, the 5 is in the tens place. So we are asking ourselves, what is 53 closer to? Well, we have two options. It's either going to be closer to 50 or it's going to be closer to 60. What sits in the middle between 50 and 60? 55. And where does 53 sit on this number line? 53 is over here between 50 and 55. That means that 53 rounds to 50. So we can sort of work backwards here and write our 50 and then include the rest of our number. 158,050 is the answer when rounding this number to the nearest tens place. How about the nearest thousands place? Same number, but now we're looking at not 53, but we're looking at 8,053. And we have two options. What's it closer to? Is it closer to 8,000 or is it closer to 9,000? Well, in the middle here between 8,000 and 9,000 sits 8,500. Now I'm looking at 8,500 and I see a 5 in the hundreds place. Here I see a 0 in the hundreds place. That means that 8,053 sits somewhere between 8,000 and 8,500. When rounding this number to the nearest thousandth place, we would round 8,053 because it sits over here to 8,000. So go ahead and plug in your 8,000 here, or excuse me, down here. Plug in your 8,000, and then you can include the rest of the number. 158,000 is 158,053 rounded to the nearest thousandth place. Now we're rounding to the millions place. In 158,053, we have ones, tens, hundreds, comma. Then you have the thousands, the 10,000s, and the 100,000s. There is no digit in the millions place as of yet. There always sits a 0. The value of the millions place right now is 0 because there's nothing there. So now we need to ask ourselves, what are our options if we're going to look at a number line? Well, you have 0 as an option because that's what's sitting there, right? Just like here, you had 50 as an option because there's a 5 there, and you have 8,000 as an option for the thousandth place because there's an 8 there. So here we have a 0 in the millions place. So that's our first option. Or we have 1 million. And sitting here between 0 and 1 million is 500,000. Now we can ask ourselves, is 158,053, is that more than 500,000 or is it less than? Well, compare the 100,000s digit. You have a 5 in the 100,000s place and you have a 1 in the 100,000s place. That makes 158,053 less than 500,000. So it's sitting somewhere around here, right? Therefore, 158,053 to the nearest millions place is actually 0, right? So rounding numbers there, rounding large numbers, but still rounding to the classic tens place and thousands place. You just got a little extra baggage over here in the 10,000s and in the 100,000s place to include after rounding the number, right? So number 3, the opposite, or excuse me, prime or composite. We're dealing with the number 7. Now, when we're dealing with the number 7, we got to ask ourselves, well, what are the factors that we can multiply together to make 7? So I look in my chart when looking for factors, find the number that you're trying to find the factors for in the multiplication table. I have a 7 here and a 7 here. That is 1 times 7 is 7. And this is 7 times 1 is 7. The only factors that 7 has on a multiplication table are 1. We have 1 times 7. So the only factors are 1, 7. That makes the number 7 prime. Okay. All right. Number 4. We are locating the greatest common factor. So the factors of 66 and the factors of 77. So the factors of 66, the factor pairs, we have 1 times 66, and it's a double digit number that has 2 of the same digits, 6 and a 6. I know it's a multiple of 11. 6 times 11. It's an even number, so 2 times something equals 66. We have 2 times 33 gives us 66. And now we sort of come to this point where maybe we've hit a roadblock and we're just not sure if 66 is made by any other factors. Now, one way to look at that is, one, you could find a multiplication table, see if 4 is a factor, right? We have already determined that 1 and 2 are factors. Why don't we go to 3? See if 3 is a factor of 66, and it's just not big enough. It's not going to take us all the way to 66. That makes using a multiplication table a little bit tricky, right? Is 4 a factor? Well, it only goes to 60, but 60 plus 4 is 64. 64 plus another 4 is 68. So I know that 4 is not going to be a factor of 66 because when continuing the multiplication table on, it does not land on 66 itself. So what do we have for factors of 66? I think I want to test out 3. How do you test out a factor? Well, you got to use long division. 66 divided by 3. That's the factor we want to see if it is included in the factor pairs of 66. 6 divided by 3 is 2. 3 times 2 is 6. Subtract, bring down, right? D, M, S, and B. 6 divided by 3 is 2 again. 3 times 2 is 6. And we see that 3 is in fact a multiple of 66 because there's no remainder when we divide by it. 22 and 3 make 66. 22 times 3. Okay. Now I can list out my factors. I have 1, 2, 3, 6, 11, 22, and 33. The factors for 77 I have 1 times 77, the factor pairs for 77. And let's see, it's an odd number, so I know 2 is not a multiple of 77. I know that 3 is not going to be a multiple of 77 because 3 times nothing gives me 7. Here I knew it was a factor because I can multiply something times 3 to make 6, each one of those 6s. So I'm kind of at a point where I'm like, okay, well, what are my options? It's anything times 9, 77. 9 times 8 is 72. 9 times 9 is 81. That's not an option. 8 times 9, 72. 8 times 10 is 80. 8 is not an option. 1 times 77 is our factor pair for 77. So we have 1 and we have 77. Common factors, we have 1, and therefore we can put a box around the 1 because it's the greatest factor that these two numbers have in common. I'm so sorry, that is so wrong. We have 2 common factors because 11 times 7 also makes 77. Let me write these appropriately. 1, 11, and 77. 1, 11, 7. That's way out of order. I'm so sorry. Should be 1, 7, 11, and 77. The greatest common factor is 11. Okay, put a square around it. There's your answer. 11 is the greatest common factor. So if 66/77 was a fraction you were dealing with and you wanted to put it in simplest form, divide 66 and 77 by 11. All right, number 5. We're going to list some multiples of each one of these, 4 and 5. We have 4, 8, 12, 16, 20, 24, 28, and 32, at least 8 multiples. Then we have 5, 10, 15, 20, 25, 30, 35, and 40. 5 times 8 is 40. I know I've listed 8 multiples. 20 is going to be the smallest multiple that 4 and 5 have in common. So we can put a little starry star around that. Right? Put a star around the least common multiple. Change that direction. Turn it into something a little easier. I am now looking at 20 as the least common multiple. That's the end of my directions there. But if you were dealing with 2 fractions, one that has a 4 as a denominator and one that has a 5 as a denominator, the common denominator of these 2 would be 20. So that's using least common multiple to help us with fractions. Complete the pattern. Well, let's take a look at how these numbers change. We were given 3, then a 9, and a 27. What do we do to 3 to make 9? Well, we could add 6, but you got to ask yourself, what do you do to 9 to make 27? Do you add 6? So adding 6 cannot be the rule that we are looking at. What's another way to start with 3 and make 9? Well, we can multiply times 3 and get 9. Is 9 times 3 27? Sure is. Our rule is to multiply times 3. So times 3, okay, multiply by 3. However you want to write that rule is fine. Okay, what are the features of this pattern? We're dealing with numbers, so it is a numeric pattern. Okay. What is the 10th number? Well, we have 1, 2, 3. So here we got to figure out what is the next number going to be, right? So we have 27. Well, the next number that we have, we got to multiply 27 times 3. So 27 times 3, 7 times 3 is 21. Put 21 over there. What I got to do something with that. I'm going to put the 1 down, and I'm going to carry the 2. 2 times 3 is 6, plus 2 is 8. 27 times 3 is 81. So our next number is 81. Now, we want to find out what the next number is. We got to multiply 81 times 3 to get that next number. So we have 1 times 3 is 3. Only have one digit, so just immediately put it down, and 8 times 3 is 24. The next number in this pattern is, we had 81, and we have 243. Then, in order to find the next number in the pattern, we got to multiply 243 times 3. So here's a great exercise to put you in a position of multiplying a 3-digit number times a 1-digit number. 3 times 3 is 9. 4 times 3 is 12. 2-digit number, put it down, circle it, got to do something with it. I'm going to put the 2 down, and I'm going to regroup my 110. Now I can multiply 2 times 3 and get 6, and then add my 1, and I end up with 729 as the next number. In order to get the next number in the pattern, 729, I can take my answer right there and I can multiply it times 3. 9 times 3, 27, 2-digit number. Circle it. Put down the 7, carry the 2. 2 times 3 is 6, plus 2 is 8. 7 times 3 is 21. So the fourth number in my pattern is 2,187. And here you are multiplying a 4-digit number times a 1-digit number, which is 3. Here we go again. 7 times 3 is 21. 2-digit number, put it down, circle it. Got to do something with it. I'm going to put this 1 down, and I'm going to regroup my 2. And once I regroup my 2, I'm going to multiply first. 8 times 3 is 24. Then I will add my 2, and I'll end up with 26. Okay. So now I'm going to put my 6 down, carry my 2. 1 times 3 is 3, plus 2 is 5, and 2 times 3 is 6. The fifth number in my pattern is 6,561. And now I am going to have to think about what is the 10th number in my pattern. Well, I found 1, 2, 3, 4, 5 numbers in this pattern. So why not take these 5 numbers and say, okay, I've already done 5. I can double it and I can make 10. So if I multiply 6,561 times 2, so this is for the 10th number, and I'm going to leave this for you to do. But if I have the 5th number, I can multiply my 5th number in my pattern. I know it's the 8th number, but for our purposes, this is the 5th number in our pattern. We can multiply that 5th number times 2. 6,561 times 2. Okay. And then, because we also have the 5th number, right, I can find the 15th number in this pattern by multiplying my 5th number by 3. Right? 5 times 3 is 15. So the 15th number, okay, I can take 6,561 and multiply that times 3. So I'm going to leave that for you to walk through, multiplying a 4-digit number times a 1-digit number. You can do that twice. All right? That's going to be your strategy for the rest of the problem number 6. All righty. Now on to number 7. In order to do number 7, why don't we open up our Google Classroom, and from there we can take a look at what problem number 7 says. It says 33 is 3 times as many as something. 33 is. That's the same thing as saying 33 is equal to 3 times some number. Okay, so 33 is equal to, if I am looking at this pattern, I am going to be working backwards. I want to take a look at 33 is. 33 is the same thing as saying 33 is equal to some number. Okay? 3 times as many as some number. 33 is equal to 3 times as many as 11. 11 times 3 is 33, or 33 is 3 times as many as 11. And then you can draw your array down there. So that's Mountain Math 1 through 7, set number 20. And within the next couple of days, you will have Mountain Math set 20, numbers 8, 9, 10, 11, and 12. All righty, guys. Take care.